All right, graphs of linear equations, specifically linear functions. All lines are functions. Other than you have vertical, those are actually don't pass the vertical line test. But graphs of linear functions, specifically linear functions form a line, right? That's where we get the term linear function. They've given us an example here. You'll often find them doing projections of scatter plots using lines. So they have a map of different things here, and they have different dots, which represent kind of a scatter plot here in your book. And to do a prediction for a scatter plot, they will draw a line that kind of goes through the center so they can kind of predict where it will fall, or at least the range that it will fall on. All right, a couple things about lines. The first thing they talk about here is finding X and Y intercepts. All right, the word intercept specifically means where it crosses that axis. So the X intercept is where this line crosses the X axis. The y-intercept is where the line crosses the y-axis, okay? So if you talk about this x-axis, there's something in common to every number on the x-axis. Your y value here on your x-axis, your y value equals 0. Because if you're on the x-axis, you have not moved up or down, right? And so if I wanted to find my x-intercept then, I could just take this and I could make my y 0 and just solve. So I have 2x now equals 6, so x is going to equal 3. That tells me my x-intercept. This line will cross this graph on the x-intercept at 3. That's where it's going to cross because that's where my y is 0. Same thing for my y-axis. For my y-axis, my x is always 0. I have not moved left or right. So to find my y-intercept then, I am just going to 0 out my x. And so I will have 0 here. So 3y equals 6, y equals 2. And that tells me where I cross the y-axis. I cross at positive 2. Now the thing about a line is once you have 2 points, you can graph it. That's all you need. Any 2 points, you can graph it. I have 2 points. So because I have 2 points here, I can just connect those dots and I will have my line. Okay? And so intercepts is one way to graph a line. Find your x-intercept, find your y-intercept, and then you can graph it. All right, and they give you the instructions for doing that. Now, here's a pattern that always erupts when you're finding your intercepts, okay? If it is in standard form, so standard form of an equation looks like this, ax plus by equals c. All right, you have your x and y on one side, you have a constant on the other. That is standard form. Then you will notice a pattern that happens with your x-intercept and with your y-intercept. If I zero out what's with my b or with my y, if I zero that out, then I'm always going to end up dividing this constant by my coefficient of my x. So my x-intercept always, always, always ends up being my c over my a, which is my constant over my x coefficient. That will always be my x-intercept. Also true for y. If I zero out my x, then when you work it out, my y-intercept will always be my constant over my my coefficient of my y, which is my b. Okay? So these will always work. You can always plug it in and solve, or you can literally just take your constant divided by your coefficient. And that will be your x or your y-intercept, depending on which coefficient you've divided by. Okay? And so if you're given one, and so they give us a graph here, for example 2. When you get to large word problems, I almost always graph with an intercept because you have these huge numbers and a slope of like 1/2. Well, if I'm talking about 1200 and I need to go up 1 and over 2, I'm never going to be able to do that on a normal graph. So intercepts is a better way to do it because then you can set your graph up to be a little more conducive to what you need it to do. And so, for example, they have given us these huge numbers here, and I'm actually going to make this. So mine is in single digits. Well, I don't want to graph this guy in single digits. I'm talking about 1200 here. So I will change this and I'll say, okay, these are actually hundreds, 100, 200, 300, 400. So I'm going to make my whole graph look like this, right? And then I can graph it using my intercepts. It's going to be way easier than what you're used to, like slope-intercept form. All right. And so if I want to find my x-intercept, I'm going to put my c, my 1200, over my -3. My x-intercept is -400. So I'm going to go to -400 on this graph. My y-intercept, that's going to be my c, 1200, over my y coefficient, right? That's going to give me a positive 300. So now I'm going to go up here. And now I can graph this particular line. Easier than if I did like a slope-intercept form, which we will be doing, all right? But this, something like this is way easier to graph with intercepts than to like put it in slope-intercept form and have a huge y-intercept and then have to go up 1 over 1. It will not be nearly as accurate as this. Slope. Slope of a line. It's represented by m. It is the ratio of the rise, how far you go up, vertical change, over the run, horizontal change. The formula that we have gone over many times since Algebra 1, y2 minus y1 over x2 minus x1. All right. When you get into sciences, you'll notice this notation right here. Delta, that triangle, capital delta is your Greek letter, always means change. Change in y over change in x, okay? So delta y over delta x, or subtract your y's over subtract your x's. Given 2 points, you can just follow your formula. Given a graph, you can legit count. So if I were given a graph, I could say, from this point to this point, I went up 1, 2, 3, I went over 1, 2. 3 over 2 would be my slope. So a graph, you can literally just walk it. If you're given numbers, you can just plug them in. All right. Look at example 3 in your book. Find the slope of the line in examples 1 and 2. If I looked at the other one, I had 0, 300, and -400, 0. Once again, I can just use my equation. Y's, subtract my y's, 300 minus 0. Subtract my x's, 0 minus a -400. All right? You'll notice that I went in the same order. So I started here and subtracted this. It doesn't matter which way you start, but your bottom one has to follow what you did on top, okay? So if I did 300 minus 0, I have to do 0 minus a -400. And when I do that, 300 minus 0 gives me 300. 0 minus a negative gives me positive 400, and that will reduce. You do want to always reduce your slope. Always reduce it. Leave it as a fraction. Do not do a mixed number if it's improper, but you do want to always reduce it. All right? Questions on this? Find the slope of the line passing through. You're going to do the same thing. Label these x1, y1, x2, y2. And you just need to subtract. Positive 8 over -12. And then, of course, reduce. All right? So they can give it to you a multitude of ways. They could give you a graph. They could give you a set of points. They could give you 2 points, okay? Types of slopes. Look at the middle of page 65. Middle of page 65. So as you find slope, finding slope's not hard. You're going to subtract your x's, subtract your y's, and you'll have a fraction. All right? Pay attention to what that tells you. A positive slope is going to be going up from left to right. So uphill. Negative slope is downhill. This guy right here is a 0 slope. That means when you subtract your y's, you get a 0. All right? This is a vertical slope. It is undefined because when you subtract your x's, you get a 0. All right? And so positive slope, negative slope, 0, undefined. If you are given a graph and you find your slope and your graph does not match what your slope is telling you, you probably did something wrong. So this is a quick check to say, at least did I get my positive negative right? Okay. And if you didn't, you need to go back and check. And did I subtract correctly? All right. And so this gives you a picture of the types of slopes you can have. All right. Types of slopes you can have. The last thing I want to do is slope and y-intercept. So slope-intercept form means that you want y by itself. So they've done it this way with just your standard form. If you have it in standard form, the first thing you would do is you would subtract your x over. So we subtracted the x over. We have by equals negative ax plus c. Then your final step here would be divide by b. So you end up with y equals your negative a over bx plus your c over b. All right, why does this help? Well, your slope is always going to be this guy in front of your x. And so if you have it in standard form, you can go straight to negative a over b. So your slope is always going to be negative a over b. And then your y-intercept we've actually already established. We already know that from the first one that we did. Your y-intercept is going to be c over b. And so if you're converting from standard to slope-intercept form, this is how it's always going to work out, which means you can graph two ways. You can graph with your intercepts, x and y-intercept, or you could just plug in your y-intercept and graph using your slope by walking from your intercept to the next one. Let's look at this example. We have the function 3x plus 2y equals 8. They want us to use the slope and the y-intercept to graph it, okay? So sometimes it may say put it in slope-intercept form. If it does, then you need to put it in slope-intercept form, all right? So if we were to put this in slope-intercept form, we would move that x over, right, by negating it. So we have 2y equals negative 3x plus 8, and then we would divide everything by that 2. And so we would get y equals negative 3 halves x plus 4. They want us to graph it using the y-intercept. Y-intercept is where it hits this axis. That's right here at positive 4. If they want me to use my slope, my top number tells me up or down. My bottom number tells me left or right. If it is a negative slope, you can either do negative 3 over positive 2 or positive 3 over negative 2. All right? Only one of your movements is negative, not both. In this case, I would actually use the first one because the second one would take me off the graph, right? So I'm going to say down 3 and right 2. I'm going to actually count 1, 2, 3 down, and I'm going to go over 1, 2. All right? And so I have counted down to where my next point is, down 3 over 2. Once you have 2 points of any line, you can graph the line. And you simply connect your 2 points, right? Better than that, hopefully. So connect your 2 points. All right? You do have arrows on the end because it is an infinite for both ways. All right? So you can graph with slope-intercept. You can graph with just your x and y intercepts. 2 ways to graph. But it's always going to end up being, you'll notice that my final answer here was negative a over b as my slope and c over b as my y-intercept, always. All right, questions on that? Find this real quick. State the slope and y-intercept. You do not have to graph it. I just want you to give me the slope and the y-intercept. Slope and y-intercept.